Okay, so we are solving problem 48 from chapter 2 of Giancoli 6th edition. So what we have is a baseball that is seen to pass upward by a window. And so let's make this window here. And we have this baseball passing up. And this window is 28 meters from the ground. So 28 meters from the ground. What else we know is that the speed of this ball is 13 meters per second. So the direction of the velocity is up. I don't know yet if this up is positive or negative. I have not chosen my frame yet. And then comes a question, which is what was the initial speed of this ball? Of course, for it to be up there, it was kicked from the ground with a certain speed, and we want to know what is it. Okay, so this is my unknown. That's the first question. Okay, to start solving this problem, let's choose a reference frame. So reference frame here is a vertical line. I'm going to choose up being positive. This is totally arbitrary, but that's my choice. Up is positive, and I'll choose this point here to be my origin, so the initial position of this ball is 0. And so if this is 0, this is plus 5, plus 10, all the way to plus 28. Very good. We have acceleration, of course. Acceleration is gravity, which is always pointing down. And according to my frame, this down means negative. So now we can solve this problem. So part A, what is this initial speed? See, I have the velocity here. I have, well, this velocity now I can say that is positive, right? I have this velocity, I have distance, but I have no information about time. So the best equation to use is this one. V squared is equal to V naught squared plus 2A delta x, right? So the velocity at this point I know is 13, so 13 squared. The initial I don't know, that's what we are after. Plus 2, the acceleration is minus 9.8, and this delta x is how much this baseball already moved, 28. From here, we will find this initial velocity. If you solve this equation, you should find that this V naught is 27 meters per second. This is the speed. If you want to be more specific and also give the direction of this velocity, you can say plus, according to this frame, up is the direction. The next question, question B. Question B is what altitude does it reach? So it goes all the way up until it stops. I know that it will have to stop somewhere, and I want to know how high up did it go from the ground all the way here to this maximum, let's call it maximum height. So what is this point? Okay, now the question is about position, and again I don't have any information about time. Best thing is again to use that same equation. V squared is V naught squared plus 2A delta x, and we want to find what is this delta x, considering that we started with that initial speed 27, okay? And we know that maximum height means 0 velocity, that's when we stop. So we just have to put these numbers there. Acceleration is minus 9.8, and find this delta x. This will give us how high we went, and if you solve this equation, you will find 37 meters. Okay, let's go to part C. How long after it was thrown did it pass the window? Let's make this question a little better. Let's say, how long after it was thrown did it pass the window for the first time? Okay, so how long after do we find the ball here by the window for the first time? Okay, so now we are asking the questions about time. We are giving position. So we're given position and we also given velocity. So there are two equations that we could use. We could use this one, x equals to x naught plus v naught t plus a over 2t squared, and find the time because I have the position. Or I could also use v equals to v naught plus at. I have the velocity, I have acceleration, I can find t. Which one you use is up to you. But I think this one, I would go for this one because this one is a linear equation. It's much easier to solve than a quadratic equation. Okay, so let's go for this one. What we know is that the velocity will be 13. Initially, it was 27. My acceleration is minus 9.8. And from here, we get the time. And the time should be 1.4 seconds. Very good. One last question, question D, is after how many more seconds does it reach the street again? Okay, so we got this baseball here right at the window. What it's going to do is it's going to move all the way up, reach this maximum height, and come back down. So we want to know how long it takes for this motion in green that I'm drawing here. Okay. One way to do that is to find the time for this whole motion from the ground back to the ground, and then subtract from this value the time that it took to go up here. Now, so I know that from the ground to the window, it took 1.4 seconds. So if I know the time that it takes for the whole motion from ground back to ground, and if I subtract from this 1.4, then I will get the time for the green motion from window back to the ground. Okay, so this is one alternative. There are others. So this is the one I'm going to use. Since I'm dealing here with, well, one way is to deal with position. So I'm going to use this equation here. And what do we know? Well, if I'm back to the ground, my position is 0. If I started from the ground, my position is 0. My initial velocity we found back up here, 27. So I'm just going to put here plus 27. Time is what I want to find. The acceleration is minus 9.8 divided by 2t squared. See, this looks like a quadratic equation, but I can cancel time and I can find this total time. So this total time, if you solve this equation, should give you 5.51 seconds. This is total time for the whole motion, but that's not what the question is asking. It's asking us the time that it takes after it passed through the window to come back down. So what I need is this 5.51 minus the time that it took to reach the window, so minus 1.4 seconds. And if we solve that, we should get 4.1 seconds. So this is the answer for this question. There are other ways to solve this problem dealing, for example, with velocity. Let me just mention another possibility. You could think of the following. Using the equation for velocity, you can use this equation to find the time for the whole motion again. And what does it mean, the time for the whole motion? You know that when you come back, you are again with 27 meters per second, but just pointing down. And so from this equation here, you can again find the total time as we found, and then subtracting from the time to get to the window, we'll go back to the answer 4.1 seconds. And there are other alternatives also to solve this problem, so use your creativity.